So let's kick off then. Once I actually have this going. Right, so just a brief bit about me. So I'm the founder of Compositional IT. We're an F# and Azure consultancy. We're based mostly in the UK, although I actually live in Germany. We do consultancy, training, development, pretty standard for many consultancies out there. The only thing is, yeah, from a .NET point of view, basically everything we do is in F#. We're big fans of that. We think it's a really compelling and productive way to develop applications, whether that's web apps, database applications, or back-end services. We pretty much do all of that in F#. Been using F# for maybe a bit more than 5 years now, maybe 6 or 7. Been a .NET developer since right at the beginning. I'm talking, I think it was called Visual Studio 7. I think it was even before it was like 2003. So .NET 1.0, before generics, the really early days. Obviously, I can't do a show of hands so easily, but what I will do is something I got from Urs Enzler a couple of weeks ago. So if I do ask you any questions or poll style things, 1 out of 10, how much do you know this stuff? Just put that into the chat window, and then at least I can quickly see a bunch of 1s or 5s or something approaching. So keep that chat window open. And in fact, why don't we just start with that? Yes or no, how many of you here are actually .NET developers today? I assume 1 is yes. I can just cast that across from bool to from int to bool. Good. Okay. So it looks like basically everyone here nearly, and I'm assuming most of you are doing Azure since this is an Azure user group. So I won't waste time on that one. In terms of F# here, is there anyone like yes or no has done anything with F# at all, or tried it out, maybe Hello World style of things? Oh, manual. Okay. Cool. Okay, so a mixed bag. More than I would have expected to say yes, but that's good. That's always a good sign. I've had user groups where I've gone to do F# or Azure and like no one has even heard of it. So that things are picking up in that regard. So I want to just review the current state of play where I think most companies are in terms of working with Azure and go through a couple of different sort of ways people are deploying infrastructure today. Talk about ARM templates, we'll talk about Pharma, look at some automation points of that, and then maybe at the end, how do I get started? So let's get going. The first question I would say is, why don't people automate infrastructure? We always talk about CI and CD, and it's important to have, a Devops or a GitHub pipeline or something where you run your unit tests and you build your code, and maybe even you create artifacts and push that to some server. People don't talk about infrastructure that much, though, in terms of continuously deploying infrastructure and making that repeatable. And this was kind of where I started with Pharma, which is, why aren't people doing this? What's stopping people getting this and, codifying their infrastructure? What are the real sort of blockers to that? So I thought the best way is, let's look at how people deploy today and talk about the benefits and the costs of each of those options. And if any of you sort of, as I'm going through these options, sort of this resonates with you, then of course feel free to put something in the chat window. So I would say that the obvious place where people start in Azure is they use the portal. I need a new web app. I'll go to the portal, I'll hit new web app and fill in some details, and I've got a web app. It's so easy. And indeed, you get a nice wizard and it's pretty easy to get started, but totally not repeatable. It really doesn't scale. So if you want to make multiple environments or anything more than a single resource, it very quickly becomes difficult, time-consuming, and expensive. And it doesn't apply to code. So the amount of times, I've had customers say to me, like, I've gone to the portal to spin up a web app. How do I get my code into the web app, though, once I provision this resource? And it's like, well, the portal doesn't really help you in that regard. Then it's more FTP client or Visual Studio or whatever, which brings us on to point number 2, which is right-click publish. And so this is, I think, not too bad. It's not too difficult a way to start. You get a wizard, but And it does infrastructure and code, which is quite nice. You can create an ASP.NET web app. You can right-click and say publish, and it will create the web app, and it will even do some config, which is pretty good. Again, it's not so easily repeatable. It doesn't scale well. It's Visual Studio only, really. And there's only a limited number of use cases. Basically, the size of this scroll bar, it doesn't really compose so well. And everyone always says, you must never do right-click publish. So, forget I showed you that slide. That didn't exist. And then we come to these kind of code-first deployments. So you've got a whole bunch of options that Microsoft have come up with over the years, starting with like the PowerShell commandlets, which is going back quite a long time now. You had the .NET Fluent SDK. Is anyone using the .NET SDK at all for this? Yeah, okay, good. At least one person. You got the Azure Client, which I was kind of skeptical at first, but I've actually grown to quite like. It's pretty flexible. It's quite powerful. You got this REST API that you can call, so you can send HTTP messages to Azure, and you've got these ARM templates, which we'll come on to in a little bit as well. And then you've got these two other ones on the side, Terraform and Pulumi as well, which are third-party options that are both multi-platform that happen to support Azure as one of those platforms. So this is a very crude diagram. It's not exactly right, but it kind of tries to set the scene of how these things live. So sort of at the bottom, you've got the Azure REST API and the Resource Manager API, and you've got the PowerShell sort of Azure Client and the .NET Fluent APIs going to Azure directly. And then you've got sort of Pulumi and Terraform that have their own sort of DSLs, their own dialects, their own ways of working, and they have their own managed state services as well. So that's kind of a third-party component that you can pay them for, or you can, I think with Pulumi at least, you can roll your own one, and it's your risk then. And they then sort of talk to Azure behind the scenes. So you have this kind of layer in the middle. And then you've got the ARM template, which kind of has its own API where you can send an ARM file there, this JSON document, and it will then do the magic for you. It's not entirely accurate, this diagram, partly because my PowerPoint skills sort of, this is as far as I can go in terms of drawing boxes. So, but that's kind of where it lays. So Pharma, if I had to say, lives on top of ARM. That's where it's positioned. So it generates ARM templates, which then go in the normal flow. And there are benefits and there are costs to this approach. So there are some pretty good things about ARM. One, it gives us this thing of idempotent deployment. So you can create an ARM template, and nearly always you can push the same template into Azure and you will get nothing changed. It will realize what's in there. It will make the changes as appropriate. The support for growing number of resources. It's cross-platform. It's just a JSON file, so you can use it in a number of ways. You've got sort of cross-tool support. And it's got this nice thing where you can record and audit deployments as well. So you can push a deployment in and it will record the exact file that you sent. It will show you what happened and so on and so forth, which is good from a sort of recording and an audit point of view. Why wouldn't you want to use it? So I would suggest there are kind of two categories of people that are using ARM or considering this kind of thing. If we look at those that are using ARM templates today, and it's probably worth me asking, how many of you are actually using ARM templates right now? Okay, so maybe 4 or 5 of you. Yep, okay. So most people that we work with, and this is also our experience, was once you get stuff out there and you've got this template working, the experience is generally positive. You can push it out, it's in code, it's all good, everything's just working. The problem is getting to that point is really difficult. Altering the templates themselves is not positive. And that's really where I see, this is the bit that Pharma tries to really improve upon. For ARM template experts, the story I've seen, and I've literally got like pictures of people on Twitter with like a beer mug, and like, I got my ARM template working today. I've deserved this nice big cup of, this nice beer now. That's kind of the, yes, well done, you did it, but we really don't want it to be like that, yeah? It's working, it's great, but it took ages to get it right. It's a pain. If you're not an ARM expert and you're a beginner, you'll probably see a few videos that people have done on ARM templates. You've thought, oh, this is what we should be doing. You then open up VS Code, you try and create a template, and you give up and you go back to the old way of doing it. Things are a bit better today, for sure, with some of the improvements in tooling support in ARM, and Bicep to an extent sort of also improves on that. But in general, I think some of the problems are still there, frankly, and it's generally, we see people trying ARM and then just going back to the portal. The best way of I could explain that is, or even for those people that have got ARM templates working, is once you've got that ARM template working, in 3 months' time, you need to then add in another resource. Are you brave enough to make a change to that ARM template and push it straight into your production and system after you've done it, or into a system and be confident that it's going to do what you want, sort of thing? And there's always that kind of nervousness around that. For those of you that are using ARM today, how do you actually, before I even show this, how do you figure out your ARM templates today? If you want to work with a resource, what techniques or tips do you use? You've got an open VS Code or Sublime or whatever. You want to create some resources. What tools or documentation or resources do you have at hand to help you come up with the right fields to understand what to do and how to do it? I'm asking anyone there who's actually doing ARM templates today. So if you're doing it, yeah. MS Docs, yeah, good. Portal export, good. One more. Let's just wait for this last person, then we'll crack on. GitHub sample repo, perfect. That's good enough for me. So first one is the GitHub samples repo, this Azure Samples 101 that Microsoft have put in, which is pretty good. It's got a whole variety of samples. The problem you end up with is you need to find the sample that has the exact resource you need. And then you have to find just the bits in that sample that give you what you want. And that's actually harder than it may sound. So you know, all right, I want to add in this field. How do I add an app setting into web apps? So you look through the GitHub portal for web apps, and then you try and scan through everyone to find the bit that you want. It's not always that easy. Community, reading blogs, check Stack Overflow, which actually is often the best way, because those are often the hard bits that the docs don't support, where you'll find someone who's written a blog about it that says, the docs have this wrong, this is how you really do it. And often that's unfortunately the state of play. Generate manually, reverse engineer a template. So you go into the portal. If it works, great, try and figure out what's going on. It's not 100% accurate. Doesn't always give you all the resources. Sometimes it will look like it worked, but it doesn't. So you can't really rely on that. Official documentation. Yeah, that sounds great, except the docs aren't really that good. A lot of them don't give you the information you need. Some of them are contradictory. Some of them just don't have the right fields in there. Some are actually giving you wrong information. I know that there's a sort of a drive in Azure teams to improve this, but at the moment, you need a combination of all of these. And even then, that's not always enough. What's wrong with the templates themselves? So the JSON, okay, fine. Generally, expensive to maintain and create. They take time. They're error prone. Even with tooling support that we have today, I still think they're error prone. Weakly typed. It's, to my mind, the wrong level of abstraction, which we'll talk about in a minute. And I think they've got pretty limited capabilities. Bicep is improving this to an extent, but JSON itself, you know, it's the way you can do sort of anything more than just declarative resourcing is putting expressions in strings and functions. It's a pretty painful experience once you go anything more than the most arbitrary limited sort of tasks that you're trying to do. And there are some things that are really bad, like you need a lot of documentation to create even these trivial templates. Documentation, I already said. And this is an interesting one in that I think you have an inconsistent experience across resources. So different Azure teams write different Azure, are responsible for their own schemas in ARM. And there's oftentimes not a consistent experience across all of them. So you might have to, you've learned one and then you come to another and you have to relearn a different way of doing it, which is not great. And the feedback loop is too slow. Sometimes the only way that your template is wrong, you've realized, is after you've deployed it, wait 5 minutes, comes back with an error. So there was this drive to improve things with tooling. So, we'll create this language server in VS Code, which will give us some feedback and some IntelliSense, or code completion and code snippets, and these sorts of things I've seen kind of, people getting really excited about. But for those of you that are .NET developers, really, code completion we've had since like C++ 6, Visual Studio 6, code snippets, a compiler, language server. This is nothing that we should be excited about. This is like, to my mind, the basic level that we should be expecting, really. I think we can do a lot better. All those things I just mentioned, it's VS Code only. So if you want to do it in Rider, you want to use it in Visual Studio or something else, tough luck, you can't. The schemas are outdated. They don't always conform with the docs. Discoverability is not great. Code snippets to me is just an excuse. It's just a quick way of creating technical debt. Yeah, if the answer to it takes too long to generate this code is we will make it easier to generate reams of code, I would rather say let's not have to write reams of code in the first place. Let's make things a bit more succinct and a bit easier, and then we don't need code snippets. And JSON, really, I think it's the same as YAML. We're using that in all sorts of places where I think it's maybe not the right tool for the job. So I don't think this is the right answer. I think we need to really rethink how we're working with ARM templates. To be fair, a lot of these slides were done in the days before Bicep even existed. So I'm glad to see Microsoft are looking at that anyway, but I think we really need to think about this a bit different. We want something that's quicker to author, quicker to read and understand, where you don't have this issue of, I've got to create an ARM template, let's block out 2 days of my time sort of thing. So this is where Farmer comes in. So what is Farmer? So the high level sort of spiel is it's a library that makes repeatable Azure deployments easy. I want to make it easy, and we may never get to this point, but the goal and vision of Farmer is that it's as easy and quick to create resources in Farmer as it would be in the portal, or even easier. Yeah, that's why I would really love it to get to. We might never get to that point, but that's the goal. The longer sort of way of looking at it, and this is slightly lower level, is it's a library for authoring and deploying Azure architectures via the ARM templates and the Azure Client. So those are the kind of two dependencies. So it sits on top of ARM templates and it uses the Azure Client for deployments if you want to. You don't have to, but that's kind of a bit that we bake in as well. So what does it give us? One, you can quickly generate ARM templates. So if all you want to do is generate ARM templates and then, thank you, Farmer, I've got there, I'll do the rest myself, you can do that. You can just use it as a way to create ARM templates and then go off and do your own thing. You can also use it as a tool to deploy the templates themselves, if you want to. It has a focus on high-level concepts, which I think is really important for people that are new to ARM and also to an extent new to Azure, where they don't know and understand why you need certain different resources in ARM templates to fit what is logically a single entity as far as you're concerned. And we also have a number of escape hatches that let you sort of get out of the Farmer pipeline and do your own thing if you absolutely need to, but still want to play with Farmer. So I think we target 3 people. One is people that are new to Azure, or at least new to ARM templates. People that are already using ARM templates but understand what the cost of them are in terms of authoring. So they want to keep their deployment pipelines but maybe don't want to author the templates. And the last one is a kind of an interesting one that Farmer allows us to do because Farmer is just a NuGet package, is it allows you to do dynamic deploy. So you can effectively dynamically generate templates at runtime because it's just code. So you could programmatically choose to create templates based on an input. So imagine that you've got a software service where a customer wants to provision one of your services that you offer. You can take in some inputs from a web app and then generate the template on the fly and actually deploy a custom resource for them. So it's not a static document if you don't want it to be. It's productive. It's type safe, runs on .NET Core, it's open source. Importantly, we have commercial support for it. So yes, it is open source, but I rather think of it as it's a commercial package that happens to have an open source free tier, rather than an open source package where we've got some people that are sort of doing stuff on the side. And it's extensible. So you can create your own sort of wrappers and your own hooks into Farmer if you want. Very important here, we just generate ARM templates. So if you use ARM templates already, what we generate is backwards compatible. There's nothing to stop you using it in that regard. So it's kind of not a huge transition in that regard. What does it look like? So architecturally, we have this notion of what we call builders. So you may have a web application. Think of this in Azure. I want to create a web app. Underneath that, this builder may create one or many ARM resources. So you may have a server farm and a web app, and maybe app insights. What we try to do is, although we let you generate these individual resources yourself, the default position is to target this level up here. We think a more opinionated way of doing things that targets the 80% of people that are doing the most common tasks is a better option to optimize for, rather than to optimize at this level, where you need to know, to create a web app, I need to create a server farm and tie them together, which oftentimes people will just not understand that. Once we've got those resources, we generate kind of an in-memory template of these different things sort of spliced together. We'll do things like create secure parameters, we'll create dependencies between them, we can create outputs as needed, and then at the very end, we'll generate an ARM template that has all of these things baked into it. If you want, we can also deploy to Azure using the Azure Client, but within a kind of a wrapper in Farmer. If you elect to do that, we also provide things like post-deploy tasks. So this is where Farmer goes away from just raw ARM templates, and we start to add a bit more intelligence if you want it. So an example of a post-deploy task might be, I'm creating a web app. I would like to deploy this ASP.NET application as an atomic action, or what appears an atomic action, after deploying the ARM template. Common tasks that I usually demo. I'm actually not going to demo all of this today. I'd rather focus on a couple of other demos that I've not really done before. But these sorts of things that I would think are normal tasks that a developer may want to do working with Azure. I want to create a storage account, set the SKU, create a web app, maybe have a dependency between the two. So the web app needs maybe the storage account key, and then add a setting to the web app, something like that. Link the two together. So what I would like to do, I'll do this one very briefly, just to give you an example of the kind of dev cycle. And then what I'll do is move to something a bit more challenging, just to show you some of the other resources we do. I'll do a real deploy. We'll trust that Azure is working today for us, and that things will all work well. So that's the end of the slides. Before I jump into code, any questions at this point? If you have them, please go ahead and ask, and we can just deal with them right now. Okay, good. So I'm going to use VS Code here. There's nothing to stop you using Visual Studio or Rider or Visual Studio for Mac or any of the other .NET sort of IDEs and tooling. You could even use Notepad if you really wanted to. Because Farmer is just a .NET library that happens to be written in F#. Don't be scared if you've not done F# before, because Farmer is designed to be kind of more of a DSL that lets you drop down if you need to. So I'm going to start from scratch here, and I'll just do a demo.fsx. So for those of you that haven't used F# before, in addition to the normal kind of write a console app, write a web app, you also have a scripting mode where you can write code and sort of execute it and experiment with the data and see how it looks like. So I'm just going to do this for now. No, in fact, to tell you what, I will actually do it as a console app, and I'll show you why in a second, actually. So let's actually, let's create a new folder here. You can see my demos are really well prepared. So let's do Farmer Zurich. No, is it Zurich or just Switzerland? It is Zurich, yeah, good. Wouldn't want to embarrass you there, man, or myself. Right, let's open up a new code instance here. So I'm going to open the terminal up, and I'm just going to create a new .NET Console app, just so you can see that there is actually no magic going on here. So .NET New Console. I haven't had to specify lang F# because I've actually set that as an environment variable on my machine. But if you're not doing that, then you'll have to type -- lang F# to get an F# app. Once I've got an F# console app, this is nothing different from the usual sort of things in F#. So once I've got this restored, I'll just write .NET run just so you can see hello world. Is there anyone here who is not using .NET Core, just using .NET Framework, or not familiar with the command line tooling here? Okay, good. So there we go, hello world. So I'm going to get rid of all this code, we don't want that, and I'm going to add a NuGet package. So I'm going to say .NET add package farmer. Is it add package? I think so. So now we're good to go. I've got farmer 1.32. We've actually got 1.4 is in beta, but that's all good. So open farmer and open farmer.builder. So those are just two namespaces. If you're coming from a C# background, that's like using, nothing different now. And let's try and create what I did before, which was a storage account and a web app. That's those kind of common tasks. So let's start with a storage account. So I'm going to say let my storage equal storage account. Then we create these little curly braces which look kind of like, and I'm going to say name equals my storage. And let's give it actually a name that is reasonable. And then if I want to create some other commands, you'll see I have a whole bunch of other ones here. So if you've been using Azure before and you've done anything with ARM, you'll see that some of these things are quite nice. Like if I wanted to create a container, I can say add a private container, my secret data. And now I've got, let's just leave that and let's see how would I deploy this? So I could then say my template equals ARM, and I want to add the resource my storage. So I've added that to the resource, and I'm going to say location. Let's do location dot. Now I get all the locations there. So we get IntelliSense, West Europe. And this is strongly typed, so if that doesn't exist, then we get a compiler error. So it's actually a proper types here. And then what I'm going to do now, I'm not going to do a proper deployment. I'm just going to emit it to an ARM template just so we can see what we've got. So I'm going to say my template, and I'm going to pipe this into writer.quickwrite. Let's call it Zurich. So this pipe here, this is just because I'm using ligatures, but it's just a bar and a right arrow. So this is like a core part of F#, which is, if you've done anything with PowerShell or Bash in the past, you're probably familiar with the idea of piping values between one call and another. So that's the same thing here. This value, this deployment guy, is being piped into this function. And I'm just going to turn on .NET Watch here. Run, no restore. So that's going to lock into a loop where every time I make a change here, it's going to then deploy it. It's going to then create an ARM template called Zurich. So we'll just wait until this is run. The only reason why this is taking a little bit of time here is just when my machine is running, sharing with Teams, it just seems to really drag its heels. But that's it. So let's open up Zurich JSON and let's move that to the side here. And then I'm going to minimize my terminal. So you can see we've got two resources. I've got the storage account, and I've also got the container underneath the storage account just by putting in that word there. And it's also created the dependency between the two automatically. So quite nice. Let's go a bit further and add a web app. So my web app equals web app. Name Isaac Web. Let's just add it in here. So I'll add another resource. Now we'll have 2 web resources in there. Now, actually, at this point, we're going to have more than 2. We're going to have more than 1 resource added. It will add 3 in now. It's going to add in the web app, a server farm, and an App Insights instance. And more than that, it's going to actually configure them all together. So here we've got a web app, which is configured with the server farm, and the name of the server farm is just the name of the web app dash farm. So we just follow a convention approach here. You can obviously override that in here. So if I wanted to change the name of the service plan, I can explicitly pass it in there. But again, we're trying to optimize for the default case, which is I just want a web app. Please give me one. We've also created an App Insights instance down here. And we've set a load of crazy values that you can never know out of the box that you need if you want App Insights and the web app to talk together in a code-free manner. So this will do a load of crazy stuff that is really poorly documented, but basically if you set all these parameters, then you run your web app, you'll get App Insights tracking everything for you. You don't have to think about it though. Now, a common question is, and a common task is, I want to set up a setting in my web app, which is going to be the connection string to my storage account. Now, if you're doing this today in Azure and you're using ARM, how do you do it today? And then feel free to actually write in the chat window. But I've seen things varying from, we don't put it in ARM, we'll deploy the storage account first, we'll look at what the key is in the portal, we'll copy that key and paste it into our source code. So we'll just hard code it in there. Not great. The next option might be, well, we'll have multiple app settings JSON files, one for live and one for dev and so on, and we'll paste them in there instead. Problem again, you're still committing stuff in source control. Or manually go into the storage account and copy settings in the portal of the web app, which is pretty good. But you've now got a manual process. So you've got to go into the portal, find the storage account, copy it. If you're doing it for multiple environments, it doesn't scale. There is a way of doing it in ARM, but it's quite complicated. But in Farmer, we make this quite easy. So we say I want to add a setting, which I'm going to call, let's say, storage key. And I want to set that to the key. Please do it. So I've just saved that. Now you'll see in our web app, what do we end up with, is another setting will get added in here shortly called storage key. And it has this weird and wonderful ARM expression that is essentially the key of the storage account. This will get evaluated by ARM when you push the template into Azure. So you never have to store a secret in code ever. Which is I think a really nice sort of option. You'll still have the secret in the app settings, but you don't have to ever store anything locally, which is nice. And of course, this can be easily sort of parameterized. We're just in .NET here, and F# being a functional language, it lets you create functions. So I could do something like create environment, and if I could spell, that would be even better. So I could say create environment name. Let's call it env name, and then I can move all of this out to there, and I'm going to create a function. And then what I could effectively do is say, well, actually the name of this will be actually that plus env name. This here as well, plus env name. Now if I want to create a dev environment, dev env now I've got a template for my dev environment, and if I want one for test, now I've got one for test. What I'm doing is calling that function with this name and then generating the data. Let's go back. So that's kind of the value proposition behind Farmer, and sort of a way of just showing you some of the things that you can do with it. There's a whole bunch more. We've still got a bit of time left, so I thought I could show you a couple more demos with something a bit more significant and actually deploy an application as well. Any questions at this point? So what are the benefits compared to Terraform is one question. So I think the difference is I would give you the same answer, Thomas, as I would as what Pulumi give you. In that Terraform is a kind of a it's not a strongly typed language in the sense it's still a, from what I understand at least, it's a DSL that you're using. Farmer is a .NET library, so you can do everything you want in here. I can download and import other NuGet packages. I could tie this in as part of a web application. I have a strong compiler, and we have a lot of nice rules in here that give us some instant feedback. So some of the things that we've done with Farmer, we really model in a way that you can't easily do without. A kind of a related question I hear is, why didn't we use C# instead of F#? Why did we go down the F# route? Firstly, F# gives us this really nice succinct syntax, which is kind of JSON-esque, which was one of the goals. But the second thing is F# has a really nice type system, which lets us capture certain rules about ARM templates that you can't easily do in other languages easily. So that was kind of part of what we wanted to do. As an example, if I go to my storage account and I put something like this in here, which if you've done anything with storage accounts, you'll know that that's an invalid one. I'm hopeful that we'll see here, we will get actually a validation error. So I can't do this at compile time, unfortunately, but at the point of generating here, you'll see storage account name max length is 24, but here is 27. So we actually have like typed validation rules against the resource names of ARM sort of services as well. We don't have all of them, to be sure, but we've got it for the most common ones that you need. And this can often save you a huge amount of time because you're typing in your template, you've put in a name, you don't have to wait until you deploy it and Azure comes back with an error. You get, ideally within a couple of seconds, here's some actual feedback as well. Not sure if that's a direct answer, Thomas, to what you were asking, but I think it gives you at least some of the benefits. And the more I show you, I think, you'll see some of the other benefits. The biggest difference I think Farmer has to both Terraform, Pulumi, and Bicep is that it works at this higher level. You don't have to create all of these child resources. You don't have to know all of them. My understanding is that all of the other ones are all one-to-one mappings with the ARM resources themselves. So you have to know how to do a lot of these resources themselves, which is quite difficult, particularly if you get to more complicated resources. And I can actually show you another one here. So, but before I even do that, one of the other nice benefits is you can use all the standard Azure tooling. So one of the extensions for Visual Studio Code is an ARM preview tool. So when I click on this guy, hopefully I will get now a nice diagram showing me all the resources that I've created. Now, I didn't create this extension. This is one that Microsoft have created for ARM resources. Because we run on top of ARM, we get all of these things for free, effectively. So that's kind of one of the reasons why we picked ARM and Azure Client, is that it allows us to get going quickly without reinventing the wheel. So you do not need shared deployment state as you rely on ARM. Is this correct? Yes, so ARM has its own effectively deployment state where it tracks all of the resources that are deployed. So we just use exactly what ARM and Bicep use today, which is Azure. That has its own sort of state tracking mechanism effectively, which is the deployment, the deployment history. That's all we use. We don't do anything else. Okay, so I'll show you a couple of examples now, or an example from the Farmer website, if I can find it. Here we go. So on the Farmer website, and I'll show you the link afterwards, we have a few tutorials, and one of them would be creating a serverless ETL. So imagine you're writing a cloud-native web app that's going to ingest some data, put it into blobs, and then maybe you've got a trigger set up in your function to read data and validate it and insert it into SQL. This is a sort of pattern that a lot of people use quite often. How would we do this in Farmer? So these are the kind of resources I think you'll need. Functions app, which is backed by a storage account, SQL, and then an app insights instance. So I'm going to try and create this now in here on the fly. So as far as I can see here, I'm just going to leave this to the left. Okay, so I'm going to create a functions app. So my functions app equals functions, and we'll call it ingestion, for example. Let's call it Isaac ingestion. And I'll fix that by adding it there. Now, already just by doing this, you'll see that we get the storage account for free, because in Azure, functions need to run with a storage account basically behind the scenes. So rather than forcing you to do that out of the box, we will automatically create one for you if you want. So let's just see if that's run. Oh yeah, of course I stopped it. So we'll get a functions app with app insights out of the box now, and it will have a storage account already linked, which is nice. If I want, I can rename the storage account though. So I can say storage account name input data. And when I save that, this will change from this auto-generated name to the one I've given it. And now I want to create a SQL server. So let's say SQL data equals SQL Server, which has a name, which will be Isaac SQL ingest, we'll call it. And then I'm going to say add databases, and I'm going to add a new SQL database whose name is validated data, and I'm going to set the SKU, and here I can sort of mouse over and see it wants a DTU SKU. So let's type that in, and I probably just have to add on SQL at this point. And now I get all the different SKUs that are available. So let's pick, I don't know, an S3, for example. The last thing I need to do is set a username, an admin username, which I'm going to be really imaginative and call Isaac. And now let's just add that resource as well. We'll say MySQL data. And the last thing I want is to set a connection string for the SQL database in the functions app so that my function can talk to SQL. So one of the things that are interesting with F# is you can't reference something until you've defined it. So I can't talk to MySQL from within the functions app unless it's above it. Now I've done that, I can say here setting, just like we did before, connection string, and then I can say MySQL data dot string, and I'll just put it in brackets here, and then the name of the database, which is validated data. I can get away without the string if I didn't want to, but for now, just in the interest of the demo, I'll show you that. Let's wait until that's run. And SQL Server, we've got blobs, we've got the database, it's done default collation, set the SKUs up and so on. You know, this is what, 15 lines of code, maybe, and this is now 150 lines of ARM that you would have had to manually type in otherwise. If I preview this, hopefully this looks fairly similar to what we had before. There we go. I've got server, database now. Interestingly, when we run this, and this is another example of where with Farm we've been quite strict in that we set the password for SQL directly in here. There is no admin password. You can't set it in here. What we don't want is for you to be typing in your SQL password in there. So what we do is we make it a parameter inside the ARM template. So if I scroll to the very top, you'll see we actually have a parameter here called password for SQL ingest, which is a secure string. So this is basically saying you have to pass this in as a parameter when you deploy the template. You can't store it at rest in this file. We don't want it in here. Please use something else like an environment variable or key vault or something else to do that. We're going to try and do a deploy here. We'll risk it. So I'm going to say deploy dot execute, and the parameter I need to pass in will be MySQL data dot password parameter, and the value, I'll just type in something random here. So obviously you wouldn't do this in the real world. Let's just do, I don't know, something like, we don't want to use quotes. And then let's put some numbers in as well, because numbers make it hard to guess a password, right? And then what have we got at the end here? Resource group name, oh yes, and obviously the name of the resource group. So let's call it Zurich test. Now, I'll stop this and we'll run it as a one-off. Now, we actually get a result back from here. Outputs. So if you've ever used ARM templates to generate outputs, you can do that here as well. So I can say output, my output, and I could do something like the storage account key or the connection string. So I could use this downstream as part of a longer pipeline. Imagine I was configuring an application after deploying the resources. I can get the secrets back out and then use it further on. I'll run this now, and hopefully we'll see something in Azure in a minute in terms of all these resources. And then while we're doing that, I'm actually going to jump to another final demo, and then we'll switch over to slides, and I'll answer some questions while we're here. So if the simple farm await is not enough, if I have to define very in detail resource, is that possible? So yes, it is, Thomas. You've got a couple of options. So one, you can drop down to the low-level ARM resources that we have. They don't cover every single property and every single field in ARM, but you can do that. So I'll just show you an example of what that looks like. So if I want to create, for example, a server farm, I can go to farmer.arm. What have we got here? Validation check failed. Almost certainly I've used a name here that is already in use, or the SQL password was invalid. Let's just have a look here and see if I can fix that one. Password seems reasonable. Isaac congestion. Maybe this has gone. Isaac SQL test. Let's just log into the portal just for this occasion and see if we can find the validation error. We usually have to depend on whether Microsoft or whether Azure returns that to us. If it doesn't, then we need to have a look at the deployments here. So let's have a look. Zurich test. And let's see if we've got a deployment in here. We're not going to be that lucky, so we have to go up to the subscription level and have a look over there. So let's have a look at activity log. Is it activity log or deployment? Here we go. Right. So this one, 28th. Oh no, that one's from ages ago, so definitely not that one. Let's have a look in the activity log again. Update resource group. So they all succeeded, so something was invalid on that resource. Most likely one of the names were in use. That's all I can think of there. Let's jump back and see if we can. Let's try it once more with some other names and values. And if we can't get it to work, then input data. Almost certainly that was the one that was bad. Isaac Funk input. Almost certainly that name was taken by someone else, hence why this failed. Go back to your question though, which was, can you drop down a level? Let's just go back into the chat window. Right. So we've got the farmer and then ARM, and then underneath this, you'll see we have every low-level resource that we support. So I can go into web, and these namespaces follow Azure, and I can go to server farm, and I can see all the fields on the right here that we support for a server farm. And these are all strongly typed, so worker size has a proper type and so on and so forth. So you can do that as one option. The other option you can do is start really simple and literally paste in some ARM JSON and embed it into Farmer. So inside Farmer, we have the option of saying ARM template, I believe. No, not ARM template. It's been a while since I used this one, but let's just have a look. It might even just be an ARM. No. ARM expression of JSON, no. There's a function somewhere here, and I should probably make it easier, because if I can't find it, how are you guys going to find it? But there's a function here that basically lets you take in any ARM string, JSON as a resource, and embed it into Farmer. So if you want to go to that level and say, I want to use Farmer for 90% of what I'm done, but actually just for a small amount, I want to do my own thing, you can inject it in as well. There's nothing to stop you doing that. There we go. So JSON to ARM resource and vice versa. So you can basically pull out from strings of JSON, here we go, and that will give you a sort of a Farmer resource that you can then inject in. And from there you can start to slowly build it up. Other question we had was, is it possible to build a Devops pipeline? Absolutely. So we actually have a farmer.net template that comes with a built-in YAML file for DevOps. So you can literally go from nothing to DevOps pipeline with basically no code. You just basically commit it into source control, make sure that you've set up the trust between your DevOps pipeline and Azure using like a secure principle, and you can just work. It can't happen that the generated ARM template fails. It can, as you just saw, depending on what happens in Azure. So I picked a name there for a storage account, which was already taken because storage accounts must be globally unique. So it can happen that that happens. It can also happen that we are generating bad ARM templates. Doesn't happen very often. We've got a relatively decent test suite, including some like regressions that go all the way through to ARM templates and back. But it can happen. So that's sort of the other example. The other option that you'll get is literally that the ARM that is spec'd in the docs is incorrect. But we try and help you as much as we can because we've gone through the pain of creating these nice sort of abstractions so that you don't have to do that yourself. So that actually has worked now. So I'm just going to go back into the portal and have a look at a Zurich test. So what do we have in here? So everything's been created there. So I've got a functions instance, app insights all fully configured, sitting on a farm. I've got a storage account with the right name, a SQL database with my server. If I go into the functions instance and then go to configuration, with a little bit of luck, we should also have a connection string, which is a connection string to the database. So the idea here is that we've really targeted basically developers, at least people in our shoes. We want to write an app. I want to host it in Azure. Please help us do it as quickly and easily as possible, but give us escape hatches if we need to do something more than that. I think we've got another question from Yari, so I'll just wait a minute for that one. And then I'll jump into my final demo. Do we still have time, Anna, for one more demo? 5-10 minutes?
Yeah, sure. No
Brilliant. Problem. Thank you. All right. So, so the question is, if one doesn't know F# yet, would you consider Farmer reason enough to learn it? So yes and no. I've certainly heard people that are using Farmer that have got no F# experience and are learning F# as a result of that. You really don't have to, though. I mean, essentially, if you just want to use Farmer in its most basic form, this is effectively the sort of thing you'll be doing. You know, you'll be creating these kind of JSON-esque things, and then a command with a string or a number or something like that, and maybe some embedded lists or arrays. You might then grow out, as I showed before, make functions and your own types and stuff. You can even, if you really want to, because these resources is just an interface called an iBuilder, you can actually create these interfaces like versions of these in C#. So if there's a resource that is not supported by Pharma, you can implement this interface in C#, come up with the right type that we expect, and off you go. And I've proved that this works. There's nothing to stop you doing that as well. But you really should learn F# anyway, just because it's a really great language. I was using C# for 10, 15 years before I got into F#, and I've never been happy with F#, and I'm, just in case you've heard about this, I'm not a mathematician. F# is not for this maths and science stuff. We're doing web apps, we're doing, data-driven apps. It's just a really great language. It's really fun. So I'll show you one last demo, and then I think we'll just jump back to the slides quickly. So what I've got here is an example of something a bit more fully featured. It's a web application. Deploy the web app and secure the app without any code, without any post sort of manual effort, literally from nothing to 100. So I'll show you the template and I'll talk through that in a minute. I've already built the web app, so it's already in here, and this is just using the normal sort of thing. So I've got a web config, magic about the web app in that regard. So what does the template look like? So I parameterized it a little bit here. I've just got some variables at the top, or values as we call them in F#. So this is like the name Farmer Isaac, and then I've created a storage account that's based on that. So Farmer Isaac storage, the web app name will be Farmer Isaac-app, and the resource group, Farmer Isaac-RG. And I've created a web app, and I've got this thing here called zip deploy. And what this says is, once we've deployed the resources, also use this nice feature in Azure Client called zip deploy to deploy this web app into the resources that you just made. So that zips up the folder that you just saw and sends it over HTTPS into the app service. Good. This run from package is basically just a nicer way of doing that. Basically uses what's called a package running model. And I've got a setting here, which is going to be the name of my storage account name. Not the password, interestingly here, not the key, just the name of the storage account. And we're going to use something which is relatively new in Azure called identities. So what this is saying is that basically this web app is going to run in some known identity that Azure is going to create. And down here, I'm going to create a storage account, and I'm going to grant that web identity access to it. And I'm going to give it a role. And I've got all these different roles here that Azure supports. So I'm going to say storage data reader, blob data reader. So the web app can read stuff from the storage account, but it can't do more. There's no keys being passed around here, no connection strings, no nothing. So I'm going to leave that deploying. And let's go back into that folder. So storage identity. Let's just run that template. So infrastructure.net run. And while that's deploying, hopefully, I'll just show you what the web app does. So this is an F# web app running on ASP.NET. This is going to look like nothing you've ever seen before, most likely, but it's basically strongly typed HTML in F#. So F#, because it's a very lightweight syntax, you can basically do HTML as code. So this is a function that takes in some classes, which we don't have any, and then some children. And I've just done some Bulma styling here, nothing crazy. I'm getting out the environment variable that I set as a setting. So if I go back there, you'll see that I said storage account name is a setting. Well, Azure will expose that as an environment variable. So I can get it straight out of here. I can then build up the URL to the storage account. And then I can use the nice new Azure identity to say, try and connect to this storage account using some well-known set of tests like environment variables, identity providers, secure passwords, things like this. The SDK takes care of all of that for me. And it will give me back a handle to my storage account using that identity that I created before. And once I've done that, I can literally just below create some table rows with like the contents of my blob account. So go get the container, get all the blobs, get all the pages of blobs, and then create some TDs in there. Now, the resources have already been deployed into Azure. And I'm actually now just running this zip deploy, which is going to copy up the contents of that folder into Azure. And it's now uploading a couple of files, just as an example, a couple of test blobs. So I'll just go back into that infrastructure program, just so you can see what it's doing here. So I'm literally taking the F# files that I've used for this app and I'm uploading them as blobs. And hopefully now we will get a new tab open over here. So this is now just spun up those resources. The app's gone in there. And because it's on the free tier, it might take a second or two to warm up. So while it's thinking about that, I'm just going to find those resources here, just so you can see it really has deployed them from nothing. So we've got, where is it? Farmer, Isaac RG, there we go. And there's the app. So it's literally now deployed it and it's connecting to my storage account without any secrets, but there's a trust between the storage account and the web app. And I'm reading from the storage account. So if I go in here, I look at Farmer Isaac Storage, which is my storage account, and I then go to, for example, the access control. You'll see here that we now have, once it wakes up, role assignments, hopefully. If I scroll down, you'll see that we've got Farmer Isaac app, which is a blob storage data reader. So it's created that all from scratch there. There's no secrets, there's nothing, there's just a trust, which is a much better way of doing it. There's nothing that can be compromised in terms of secrets. If you want to stop access to one app but leave others, you can do that independently. There's no sort of passwords to chuck around. So a couple of more questions. So got one from Marco here, which is, how do you keep up with the changes in Azure? Do you generate any generators from any endpoints? So no, we don't actually. So that's definitely a cost of Farmer, to be sure, compared to the other options like Bicep, where they're all auto-generated from the endpoints. We've elected not to do that at the moment. We're considering investing time in doing something like that. The problem we've got is that because with these abstractions are kind of high level and optimized, it's very difficult to automatically generate this kind of SDK from a much lower level one. Like this grant access thing, if we look at like the actual JSON that was generated from there, this stuff is like, it's not easy to know what it's really doing. It's like, you've got to know this is turning on the identity for the web app. Okay, that's not too bad. But then when you want to do the granting of the identities, you have to create, where is it here? So, right. You have to create a principal whose name is this really strange one where it's the name of the storage plus a GUID that you have to generate. You've got to set the principal and the role definition. You've got to do all these other things. It's like this stuff, if you don't know how to do it, takes hours to figure this stuff out. And even if you know how to do it, it's still not easy. Here it's like, it's pretty, you know, we've abstracted a lot of that stuff away. So yes, we may use that in the future just to get us started, but we would probably never be in a position where we would, you know, like what Pulumi have now, where they can almost automatically update from the APIs. Are global variables modeled for naming conventions? Is structuring in like modules possible? Yep. So yeah, F#'s got modules. So you can definitely sort of scope things at that level. I assume that's what your question was, Victor. In F#, because in F# everything is immutable by default. So if I create a value here called let x equals, you know, 1, 2, 3, I can't actually change it to actually get a compiler error. It says the value is not mutable. So actually having global sort of values is not actually got the same sort of level of danger as you would in other languages that have mutable data by default. What about when we want to destroy certain resources? So we do have an option, so you can destroy the whole resource group if you want. The other option you've got is when you're deploying ARM templates, you can effectively set up the deployment. Say, if there's something in Azure that is not in the ARM template, remove it. So I personally never use that. I don't quite feel comfortable with that kind of destructive model. But if that's what you want, you can set ARM up that way as well. Right. I'll keep answering questions as they're coming, but I'm just going to jump back to the slides in the meantime. So just to recap some of the use cases for Pharma. So one, authoring ARM templates. For those of you that have been doing ARM templates already, I'm hoping that that was somewhat eye-opening and a useful exercise in how you can generate them pretty quickly, and the difference in complexity and size. I didn't really belabor the point too much there, but effectively, you know, it's normally in our experience it's between 5 and 8 times smaller than ARM. And even for Bicep, it's still pretty much smaller because of the high level of abstraction. Another question, what happens when we need to access resources that were already created? So if you're talking about through code, effectively it's however you want to do it. So it depends on what security model you want to set up. If you want to get, for example, a secret out of a deployment, you can use the outputs feature in ARM. So you can say, when I'm deploying this resource, return back to me the access token or the security policy or the security token. You can then carry on using that in F#. But I'll wait. I can see you're typing, so I'll wait for you to come up with the next question. Ids of Resources. So the names of them, are you referring to? Or, I mean, if you want to unmute yourself and just talk now, go ahead and do that. You don't have to just type. When you want to link resources, so if that's like, I've created a storage account and I want to link the web app, so you can, most of the time we will do that automatically for you. The Pharma's smart enough to figure out most of the dependencies. If you want to manually do it, you can manually tie them in as well. So you can sort of say, add a dependency between this resource and that one. If that's not the answer, Victor, just drop me an email. And if we've got time after this, we can talk as well, for sure. Parts of build scripts. So if you've got a build script that's deploying your apps, well, deploy your resources at the same time, your infrastructure. Nothing to stop you doing that. And we do that quite often. CI/CD pipelines we've already touched on, so I'll leave that. And as part of a running app, again, as I touched on before. So there's nothing to stop you sort of programmatically creating resources. .NET, just in case, I mean, most of you are .NET users, but just don't forget what the benefits you get with working with that. You get a proper programming language. I mean, it sounds silly, but you really do. So you can do things like loops, comprehensions, you know, if-thens are like easy to do. You get a type system. You get a massive ecosystem of NuGet packages, you know. So if you want to, I don't know, generate names in a certain way, there's probably a NuGet package that will help you do it. You get a compiler, which is actually really useful. You get refactorings. You want to rename you know, something, hit F2, do something with it. You get a huge amount of escape hatches and flexibility. So it's just a really nice way of working. You know, I didn't have to, or anyone who's worked on Pharma, didn't have to worry about IntelliSense or compilers. That's all done for us. So it's a good way of doing it. Conversely, or at the same time, we also benefit from the things that ARM has. So we get the client, we get the portal, I can see all the deployments in there, we get the viz tools, you get the deployment history. So I didn't show that before, but I'll just show it very, very quickly now. So if I go back here, and then I jump into the portal, and then go back to my Isaac RG, and then go to deployments, you'll see that we actually get the real deployment history there. Every time we do it, I can see it's succeeded. I can see all the inputs, all the outputs. It's all there. So you're not losing any of that stuff.
Sorry, with slides.
Sorry, Victor, go on.
Sorry, we see the slides. Didn't see what you showed us.
Oh, brilliant. Is that Teams? Is that, sorry. Thanks for letting me know. Right, here we go. So I'm in the portal now. Is that okay now? Yep, thank you.
No, still can't see it. Okay.
Okay, good. Sorry about that. I'll send you a screenshot. But basically, it's you can log into the portal and look at. Yep. So we talked about that. Farmer, yes, it does use F#. It's a DSL, so it's kind of a constrained sort of look at F#. You have to learn all of it, and we deliberately tried to avoid making you have to learn a lot of the bits of F# if you really don't want to. But it's really not hard. In fact, I would even argue today F# is a simpler language in terms of surface area than C#. You may be surprised, but if you tried it, you probably are going to be surprised. It's actually a simpler language these days. It really isn't hard. You really want to try it, in my opinion. If you're using C# or .NET today, you can consume F# from C# and vice versa. So you could have your F# farmer template, make that a function, which just shows up as a static class with a static method in C#. Off you go. I touched on already, you can create new abstractions in C#, but just to remind you, if you already are doing ARM today, and you've managed to create some relatively complex templates, I promise you, F# is nowhere near as difficult and as painful as some of ARM is today. So, good. What can't Farmer do, or what don't we allow Farmer to do? There are no arbitrary parameters. The only parameters we ask for are the secrets, like you saw with SQL. Everything else you parameterize in F#. It's just the easiest way to work. There are no variables. You don't need them. If you want variables, do them in F#. It's just let x equals, off you go. There's no support for linked templates. We've really not seen need for that. Most people don't need it, to be honest. You've got enough flexibility in Farmer. And we don't support every feature of every resource. And we don't support every resource either. That's always been our kind of position, is we will start with the most common use cases for every resource. And as people ask, we'll add in more. Totally, it's worked for us so far, and it just means we don't waste time doing a feature that no one uses. What's the feature plan? So continue to add in more ARM resources. To be honest, we're seeing less and less though. 1.4, we've added in a couple more resources, but we already support, I think, the majority. Subscription level resources is something we've heard from. We have got a PR for that. It will probably just get pushed back to Farmer 2 though. Better typing, so smarter validation, reducing errors through types, but we also want to stay pragmatic. We don't want to turn Farmer into some kind of Haskell type crazy system. So there are certain compromises we make along the way. Make the API even easier to use and better through feedback. And we're thinking making custom modules for certain difficult to use parts. So if you're using things like ADF, Azure Data Factory, or Logic apps, they come in ARM with their own kind of embedded language in the ARM template that you have to basically splice in. And we're considering, depending on customer demand, making a DSL to create those kind of X-data sort of things that you can splice in. So if that's something you're interested in, let us know. I'm definitely interested in talking with you. Live reference data is a kind of, that's something that ARM actually already has with the schemas. So one of the things F# has is this thing called type providers. So you can basically bring types into the language based on distant data as you're typing. So what we would like to be able to have is like VM images, so that you could say vm.images and get a live list as you're typing of all virtual machine images in the marketplace, for example. That's something that is not a sort of a high priority, but it would be really cool to get that kind of thing. Really help, I think, bring Farmer to life in that regard. We've got 5-6 minutes, so I'll just go through very, very quickly the sort of thing I touched on with types, and then we've got 5 minutes for any other Q&A. So if you think about storage SKUs, if you've done anything with them, you have two versions of like general purpose. You've got files, you've got blobs, you've got block blobs. There's replication models, there's performance tiers. You've got these kind of 3 or 4 different things, all kind of dimensions playing with one another. How do you work them together? If you look on the Azure docs, you'll find this thing called a SKU object, which tells you some stuff, but it won't tell you everything. You then find another page, which gives you information about the kind. you'll find another page that tells you about access tier, and then you'll find another table which actually isn't quite right, that will try and give you the different combinations of them all as well. If you're trying to figure this stuff out, it's really not easy to know what you can and can't do, but in F# we actually encoded this. Oh, and here's another table of different SKU types as well. We were able to encode it in basically 7 lines of code, 8 lines of code, to say, well, we've got 4 types of SKU. General purpose has got V1 or V2, and V1 has got LRS, GRS, or RAGers, and if it's LRS, it's either standard or premium. And V2 has got a similar thing, except it's got different replication types. This is like, there is no sort of hidden magic now. It's just the types are telling us the story of what is really going on. There's no need to document this. You can read this and pretty much see what's going on. And that's what it looks like. Okay, I've already touched on the 80-20 thing. I talked about opinionated. How do I get started? Download .NET Core. If you're on VS Code, you can download the Ironide extension for F#. If you've got VS 2019 or Rider, you've already got F# support. You can use the template, farmer.template, to get going, but you've seen how easy it is. It's just new console, add package farmer. I'll show you the doc site and then I'll answer the most obvious questions about Pulumi. So compositional IT, GitHub IO Farmer. If you Google Farmer Azure, it's the first starts. We've got tutorials for like slightly more complicated use cases. So how do I create a Cosmos DB application with a web app? We've got docs for every single API that we push out. So I've been quite strict with people that are contributing. Everything must be documented. So every single keyword we've put in here. We've got samples, there's scripts, examples in the code base. So hopefully there's enough there that you've got to sort of get started. We also have a commercial support package, as I mentioned. So we're very clear about this. If you want to use it for free, go ahead, do it. GitHub issue reporting, nothing more. There's no guarantees we'll answer the issues or even that we will respond to them. There's no SLA. Don't have any other contact than the GitHub issues. If you're using it in non-production, go ahead. If you're using it in production, I would suggest going for a contract with us where we'll give you dedicated support, get email, phone. We'll even chuck in an hour or 2 every month if you want actually advice on ARM and Farmer. Right. Pulumi, if anyone is using Pulumi, it's brilliant. It's really good. I like it. They've got some F# guys working on there as well, so even better. Try it out. I would say Farmer does not compete directly with it. Farmer is a single platform in Azure. Pulumi is multi-platform. We directly live on top of ARM templates, which gives us some benefits and some costs. And we have these handcrafted abstractions. Pulumi is a one-to-one mapping with what? So there are some pros and cons and trade-offs to that. Bicep, if you're using ARM, then move over to Bicep. If you don't use Farmer or Pulumi or Terraform, at least start looking at Bicep. It's a slimmer version of ARM. The good thing is it's a one-to-one mapping. So everything that ARM supports, Bicep also supports out of the box. So you've instantly got that kind of migration path, but it's a one-to-one mapping. So all the same problems in terms of abstraction remain. So it's definitely looking better than ARM. It's still not Turing complete, so you still can't go out of the box. It's still alpha. I don't know when V1 is. I think they're nearly at V3 now. So, it's still early days. I'm sure they'll get there. They're building a completely new ecosystem. So if your argument for not learning Farmer is you don't want to learn a new language, well, Bicep is an entirely new language as well. You're going to have to learn that. You're going to have to learn the CLI tooling, the IDE tooling. They've got to build a compiler. All of that you're going to have to learn as well. So, yeah, it swings and roundabouts. How can you get involved with Farmer? So try it out, please. You can contribute to the project, just feedback, documentation, requests, or add new resources. Share knowledge with others. There are lots of people that didn't know about Farmer and they've come to me and said, I wish I knew it 3 months ago. So if you've got someone that's using ARM, just mention it to report. I'll leave that link open. It's on the video, right, Manu? So they can look at it later.